Section 5.5, how to graph inequalities or system of inequalities in two variables. So to do this, I'm going to start by showing you how to graph inequalities in two variables with only one equation. Say I want to graph x bigger than x plus, y bigger than x plus 2. To do this, just think about, switch that inequality sign. If it's bigger, less, bigger than, or less than or equal, just make it equal to, and then graph this straight line. The easiest way usually to graph is using intercepts. So set x 0, y would be 2. If you set y 0, let's see, put 0 here, you get x plus 2, 0, x is negative 2. So we got 2 points here, 2 points to plot. First one 0, 2, that's the first one. Second one negative 2, 0, so that's the next one. Now when you draw the straight line, you draw a dashed line, not a solid line. So it's a dashed line because it's only bigger than, And then to shade this one, so what this is saying, bigger means we shade it. So bigger means above the line. So notice how this straight line, y equals x plus 2, split the entire plane into one region above it and one region below it. So what we're going to do is shade the region above it, this region here. Another way is we call testing points. We'll come back to that later. But y bigger means you shade the region above the line. If it's less or less than or equal, you shade below the line. So now how do I know if it's going to be dotted line or solid line? Before I show that, whatever I just shaded, this region here, I'm going to write capital S. So that means this region contains all the solutions to that inequality. In other words, if you have to pick any point, say here or here or here or here, any point within the shaded region, even on the y-axis, and substitute into the given inequality, that will satisfy inequality. It means you got a number, let's say 5 bigger than 2, 10 bigger than 7. You're not going to get 11 bigger than 20. That's not going to happen. So it will satisfy that inequality. Any point you pick below the line, below the region, so somewhere here, let's say I'm going to pick 1, 1. So let's say I'm going to pick 1, 1. Notice how this makes the inequality false. So if I want to test 1, 1, the point 1, 1, that makes it 1 for y bigger than 1 for x plus 2. So what we get, 1 bigger than 3. Do you see how it's false? So the region below the line, this line, specifically this line, it's the false region. The one above it is the true region or the solution region. So in general now, what we have, if we have the inequality is either less or only bigger, we use dotted lines. If the inequality less than or equal, bigger than or equal, we use solid lines. Again, if we have bigger or bigger than or equal, we shade the region located above the line, above or to the right if it's a vertical line, above or to the right, above the line. Line means straight line here. If it's only less or less than or equal, you shade the region located below or to the left. Of the line. Another thing you need to be careful about, when they give us an equation, or inequality to graph it, make sure that the equation is written in the form y less or less than or equal or bigger than or equal something, let's say mx plus p. So make sure y is on the left side by itself. There's nothing on the left side beside y. So always you want to get y by itself first. So basically solve for y. To show you an example on this in a minute, let me first go over a slightly different kind of example. Let's say we are asked to graph this inequality. There is a video I showed specifically for this class, Math 8, on the calculator, how you can even graph such thing on the calculator. So check that video out on the playlist for Math 8. You will see it there. So I'm gonna graph this one first by rewriting this as -1/2 x, like so. And what we can do, we can take x equals 0 and get the y value. Y is 0, so it's gonna go through the origin. You can take, if you take y 0, x will be 0. It's not gonna help us. Take x equals 2 to make the y easy to calculate. -1/2 times 2. So you get a -1. So when x is 2, y is -1. So we get this one, and notice it's the inequality is less than or equal, so it's gonna be a solid line. It's gonna be solid line. Since it's less than or equal, so we shade the region below the line. So this region is the solution region. So any point you pick in this region, it will satisfy the inequality sign. So that's the solution region. What about if we look at another one, a different one? Graph y bigger than 3. So we're going to graph it first as if it's y equals 3. Y equals 3, that means if I take x equals 0, y is 3. If I take x equals 1, y is 3. If you take any x value, y will be always 3. So 0, 3, 1, 3, 2, 3. So that will give us a horizontal line. 0, 3. Y bigger than. Now it's only bigger than. This means it must be a dashed line or dotted line, not solid line. So I'm changing it to a dotted line. And it says bigger than. Bigger means it's either above or below the line. So in this case, it's above the line because it's bigger than. So this shaded region is the solution. Notice when I graph it, I label the x, the y, the origin, the straight line, the 3. You can write y equals 3. It makes it easier for the reader to understand it. What about if we graph something that has only x in it? So x less than or equal -1. Again, we're going to graph the straight line x equals -1. So if x -1, what is y? Well, it could be 0, could be 1, could be 2. So -1, 0, -1, 1, -1, 2. So that's the straight line. Notice I graphed it as a solid line. I graphed it as a solid line because it's or equal, less than or equal. So this vertical line splits the region in half, one to its left side and one to its right side. So what I'm going to do is shade the region to its left side because it's less. If it was bigger or bigger or equal, we shade to the right. So this region here is the solution region. Next one. Let's graph. It doesn't have to be a straight line. What about if it's a quadratic thing? Okay. And I'm going to graph this one using testing points. So I'm going to graph it and check it using testing points. So let's check. First thing is, we know how the graph this looks like. If you take x equals 0, y 0. If you take 1, you get 1. If you take 2, you get 4. If you take -1, you get 1. And this keeps going on and on. It's a parabola. That's the graph so far. And what we need, the graph splits the plane into region above it and one below it. So it says bigger than or equal. So we're going to shade the region above it. But let's use testing points. Testing points to double check this. Testing points means you can pick any point you like as long as it's not on the graph of this parabola. So pick any point you like. Let's say I'm going to pick this point 0, 1. So pick 0, 1 and substitute this. Substitute into the given inequality. X is 0 and y 1. What do I get? 1 bigger than or equal to 0. Is that true? Yes, it's true. So the region that contains that point is a true region, means it's the region that I must shade. So it's this region. That's really the region above the parabola, as you can see. That's the region above the parabola. So that's called testing point. If you happen to take a point below that graph, let's say 1, 0, it's going to give us a false result. What can be other cases here? What about if they ask us to graph something like 2x minus 5y less than 0, something like this. So how do we do this? Actually, let me make it 10 here. So what I'm gonna do here, I'm going to graph this one and then use testing points. So just pretend it's an equal sign. Pick x equals 0. What do we get? Negative 5y is 10, so y is negative 2. So we get 0, negative 2. That's a point. If you pick y 0, you get 2x equals 10, so x equals 5. So 5 comma 0, that's another point. So we have these 2 points here. So what we're going to do is we are going to graph these 2 points. So we have 0, negative 2, and 5. 1, 2, 3, 4, 5. 5, 0. So I have the 2 points and I'm going to connect them. So I used intercepts to graph this. So I drew it as a solid line, but it's supposed to be a dotted line because it's only less than. So what are we going to do? We could change it now to a dotted line, as you can see. So that tells us we don't include the points on the line itself. This is 5, negative 2. Now we're going to pick a testing point. So pick or select a testing point. Most students or teachers, they select 0, 0 if it's not located on the line. I didn't choose it in the previous example because 0, 0 was exactly on the graph. That's why I didn't choose it. So here it's not, so I choose 0, 0. And let me rewrite the given inequality one more time. 2x minus 5y less than 10. So if you substitute the 0 in, 2 times 0 minus 5 times 0, is this going to be less than 10? Well, let's see. 0 minus 0, is that less than 10? 0 less than 10? Yes, it is. So that's a true result, true fact. So the region containing the origin is the true region. So this region here is the solution region, because the line split the entire plane into a region above it, which includes the origin, and a region below it, which does not include the origin. So that region is the solution region for this kind of inequality. Again, you're welcome always to pause the video when I give a new example and then try it first before you see the solutions or how I'm doing it. So this is another one. Maybe you want to pause the video right now and then try it. And then after you try it, you come back and check, see if your answer matches mine or not. So what is the first thing I do? I just convert this by rewriting it as equation to help me to graph it. The easiest way, I take x equals 0. I got 2y is 6, so y is 3. So that gives me a point 0, comma 3. If you take y 0, you get 3x equals 6, x equals 2. So 2, comma 0. So then x, y, 0, 3, 1, 2, 3. And then 2, 0. So then you're going to put that, graph it this way. 0, 2, and 3. Now, it doesn't mean like if it's bigger than or equal in this case, means I'm going to shade right away the region above it. Remember, because it has to be written in the y bigger than or less than or bigger than or equal or less than or equal something. So it has to be y by itself, but y is not there, so I cannot trust this inequality in that sense. So what do we do in this case? We pick a testing point. 0, 0 would be the easiest. We rewrite the inequality. 2x plus 2y, 3x plus 2y is bigger than or equal to 6. So 3 times 0 plus 2 times 0 bigger than or equal to 6. You got 0 bigger than or equal to 6. That's false, right? That's false. So the region that contains the origin is not a solution region. So it has to be the other region, this region here. That's a solution region. Now, how about if they give me more than one equation, like system of inequalities? System of inequalities. So let's say I'm asked to graph something like this: y bigger than x minus 1, or y less than or equal negative x. So two at the same time means I'm gonna graph these two together on the same xy plane, not two separate ones. So let's see, why do we have to do this? I always label the xy, the origin, put the arrows. For the first one, always take it this way. If you take x equals 0, y would be negative 1. If you take x equals 1, y would be 0. So I get a point here, 0, negative 1. The other point, 1, 0. And it must be a dotted line. It must be a dotted line, because it's only bigger than. Now, how am I going to shade this? Which one? Well, since y is already bigger than just y by itself, as you can see from here, and bigger means higher, so I'm going to shade the region above the line. So we're going to shade the region above the line. And what we do here, what we can do is, if we want to do it for the second one, we're going to graph y equals negative x. Y equals negative x by replacing x with 0, and that will give me y equals 0. X equals 1, y equals negative 1. So I have 2.00, and the other one, 1, negative 1. So it's here. And it's a solid line. A solid line. And which one do I shade? Do you see, if I look at this, it's really less. It's already by itself. Y is by itself. So it's less. Less means to the left side, or below the line. So it's below the line in this case. So this is the one I'm shading. Now, where is the solution here for both at the same time? This is the solution. That's where the two regions overlap. That's the solution region. So the overlapping region is the solution region. So this means if you choose or pick any point within that region and substitute in both inequalities, it will satisfy both at the same time. Because if you pick something in the yellow region only, or only in the blue region, it can satisfy only one of them. In the white region down on the right side, it will not satisfy either one of them. The overlapping is the solution. The overlapping is the solution region we're looking for. How about something like this? Graph and solve this inequality. Y bigger than or equal 2 to the x, and 2x plus 3y is less than 6. Is less than 6. So how do we start with such inequality? So the first one is something we graphed in previous sections, but let's do it again. So assume it's y equals 2 to the x, and let's pick values for x. 0 is the easiest one. 2 to the 0 is 1. If you take 1, you get 2. If you take 2, you get 4. If you take negative 1, you get 2 to the negative 1, which is 1/2. So I got a 4.01. That's one of them. 1, 2, 2, 4. Negative 1, 1/2. So this is the graph. This is the graph, as you can see. So y bigger than, bigger means because y by itself, bigger means above the curve. This is above. You see, this is the region above it. This is what we need for the first one. That's the first one. Now to graph the second one, I'm gonna graph the second one. Assume it's 2x plus 3y equals 6. If you take x0, you see 3y is 6, so y is 2. If you take y0, using intercepts here, so 2x is 6, x is 3. So that gives me the first point, 0, 2 here. The second point, 3, 0 there. And it's a dashed line. Not it's a dotted line like this, not a solid line. I labeled everything, and now it's not y less than. Do you see, it's not written as y less than or y bigger than or something. So what we have to do is pick a testing point. So let's pick 0, 0 and substitute into the inequality, and let's see what we get. If you substitute 0 here, you get 0 plus 0 less than 6. Is 0 less than 6? Yes, it is true. 0 less than 6. So the region containing the origin is a solution. So this means I'm going to shade the region below the line where the origin is located, as you can see. Okay, so then the shaded part, you know, the part that is here, the overlapping, this is the solution region. This is the solution region. So any point you choose in there, it will satisfy the inequality. Any point. Satisfy both of them actually. So let's say someone asks you to graph or solve. Let's take more than one, more than two. X bigger than or equal to 0, y bigger than or equal to 0, x plus y bigger than or equal to 1. So how are we going to graph inequality like this? Okay, so how do we graph something like this? Start with the first one, x equals 0. X equals 0, that's always the y-axis. So this is actually the y-axis. So where's the y-axis? This is x equals 0. It says bigger than or equal. Bigger means to the right side. So we're going to shade the region to the right side of this, of the y-axis. The second one, y equals 0. So y equals 0, that's the x-axis. That's y equals 0. There's above it or below it. So, but it says bigger than or equal, so it's above it. So we're going to shade the region above the line, above y equals 0. Okay, that's for the second one. For the third one, we got x plus y equals 1. So if you set x equals 0, y is 1. If you set y 0, x is 1. So we get 2 points, 0, 1, so that's the first one, and 1, 0, so that's the second one. And it must be a solid line because it's or equal. Now, if you pick a testing point, say 0, 0. So pick the testing point 0, 0. What do we get? For x plus y bigger than or equal to 1. Let's test it out. 0 plus 0 bigger than or equal to 1. 0 bigger than or equal to 1. That's false. So this means the region located, the region that includes the origin. The region containing the origin does not include the solution, so it's a false region. So we must shade the region above the line. We must shade the region above the line, like so. So I'm using different colors. In this case, it's easier to see it. It's easier to see where the solution is going to be. So in this case, where's the solution? They all overlap here. So it's kind of like the borderline. I'm going to highlight the borderline like this and then this. And of course, this region opens forever. But on the left side is bounded by the y-axis, and it's bounded by this slanted line then and the x-axis. So that's the region containing the solutions. One other example here about graphing from a given equations. So let's say we're asked to graph x less than or equal to -2 and x bigger than or equal to 1. So what do we do here? X, 0, y. So the first equation you can think about as x equals -2. So you have a -1, -2. So it's going to be a vertical line, -2. Less than or equal means to the left side. Less than or equal means to the left side. The next equation, x equals 1. Where's x equals 1? X equals 1 means it could be 1, 0, 1, 1, 1, 2. So it's another vertical line. And it says bigger than or equal. Bigger than or equal means to the right side. And we need to see where do the two of them overlap. Notice the two equations or the two shaded region did not overlap, and they will never. So we see that there's no overlapping. Since there's no overlapping, so the given inequality or system of inequalities given system of inequalities has no solution. So this is like a homework problem, and then ask you graph this. In the back of the book they would say no solution. They would say no solution. Can they represent this as a word problem? Like they ask us to do it as a word problem. The sum of twice x and 3 times y is no more than 6. Write an inequality and graph the solutions as we did above. So we're gonna graph the solutions after we come up with the inequality. So the inequality is missing here. So it says the sum of what? Twice x. Twice x means 2x. And 3 times y, 3y. No more than 6. No more means less than or equal to 6. So now I got an inequality. I set it up and I'm gonna graph it. How do we graph it? As we graphed the other ones earlier. So we said we rewrite it as equation first. Take x equals 0, you got y2. Take y0, you got x3. So 0, 2, 1, 2, 3, 0. So we connect them, put the arrows. It's a straight line, solid straight line, because it's all equal. And now we pick a testing point. Pick the origin, is the easiest. Substitute in, you get 0 plus 0 less than or equal to 6. 0 less than or equal to 6. Is that correct? Yes, that's true. So in this case, what we do, we shade the region that contains the origin, which is this one. It exactly falls below the line. So that would be the solution region.